Morning students, I am Usha, PGT Physics, working in G.K.Jain High Secondary School, Rayapuram, Chennai 13. Today we are going to see 12th Standard Physics, Chapter 1 Electrostatics in video presentation.
Electromagnetism is one of the most important branches of physics. The force we experience in everyday life are electromagnetic in nature except gravity. When an object is pushed, the atom in our hand interact with the atoms in the object, and the interaction is basically electromagnetic in nature. Same way, we can give many examples. Greeks noticed that amber, a solid translucent material formed from the resin of a fossilized tree, after rubbing with animal fur, attracted small pieces of leaves and dust. Initially, they thought that the amber has the special property, but later they found the glass rod rubbed with silk cloth attract piece of paper. For example, a charged rubber rod hanging from a thread and another charged rubber rod brought nearer, they repel each other, which shows that like charges repels each other. When glass rod are brought near the rubber rod, they come closer, which shows that unlike charges attract each other. Benjamin called one type of charges as positive charge, that is glass rod rubbed with silk cloth, and the another charge, that is amber, which is rubbed with animal fur, as negative charges. Basic property of charges. First one is electric charge. So most objects in the universe are made up of atoms, which are turned or made up of proton, neutron and electrons. These particles have mass and inherent property of particles. The electric charges is another intrinsic and fundamental property of particles. The SI unit of charge is coulomb. Second point, conservation of charges. Benjamin Franklin argued that when one object is rubbed with another object, charges get transferred from one form to the other. This is called conservation of total charges and is one of the fundamental conservation law in physics. It is stated more generally in the following way. The total electric charge in the universe is constant and the charge can neither be created nor be destroyed. In any physical process, the net charge in charge will always be zero. Quantization of charge. The quantization of charge is denoted by a symbol Q, which is equal to Ne, where E denotes the fundamental unit of charge. The charge Q on any object is equal to an integral multiple of this fundamental unit of charge E. Here N is an integer. It takes an value 0, plus or minus 1, plus or minus 2, etc. This is called quantization of electric charges. Next, we are going into the next topic, which is called Coulomb's law. Coulomb reduces the expression for the force between two stationary point charges in vacuum or free space. Consider two charges Q1 and Q2 at rest in vacuum and separated by a distance of r. According to Coulomb, the force on the point charge Q2 exerted by another point charge Q1 is F21 vector is equal to K Q1 Q2 divided by R square into R12 vector, where R12 cap is the unit vector directed from charge Q1 to charge Q2 and K is the proportionality constant. Important aspect of Coulomb's law. Coulomb stated that the electrostatic force is directly proportional to the product of the magnitude of the 2 point charges and is inversely proportional to the square of the distance between the 2 point charges. The force on the charge Q2 exerted by the charge Q1 always lies along the line joining the two charges. R12 vector pointing from charge Q1 to Q2, and in the same way R21 vector is pointing from the charge Q2 to Q1. In SI unit, K is equal to 1 by 4 pi epsilon naught and its value is 9 into 10 power 9 Newton meter square Coulomb square. Hence, epsilon naught is the permittivity of free space or vacuum, and the value of epsilon naught is equal to 1 by 4 pi K, which is equal to 8.85 into 10 power minus 12 Coulomb square Newton per minus 1 meter per minus 2. Coulomb's law has same structure as Newton's law of gravitation. Both are inversely proportional to the square of the distance between the particles. The electrostatic force is directly proportional to the product of the magnitude of 2 point charges, and gravitational force is directly proportional to the product of two masses. The gravitational force between two masses is always attractive, but Coulomb's force between two charges can be attractive or repulsive depending on the nature of the charges. The value of gravitational constant G is equal to 6.626 into 10 power minus 11 Newton meter square kg per minus 2. The value of the constant K in Coulomb's law is K is equal to 9 into 10 power 9 Newton meter square Coulomb per minus 2. Since K is much more greater than G, the electrostatic force is always greater in magnitude than gravitational force for smaller size objects. The gravitational force between two masses is independent of the medium. But the electrostatic force between the two charges depends on nature of the medium in which the two charges are kept at rest. Coulomb's law explains the interaction between 2 point charges. If there are more than two charges, the superposition principle explains the interaction between multiple charges. According to this superposition principle, the total force acting on a given charge is equal to the vector sum of forces exerted on it by all the other charges. Consider a system of n charges, namely Q1, Q2, Q3, etc. up to Q1. The force on Q1 exerted by the charge Q2, F12 vector is equal to A into Q1, Q2 divided by R21 square into R21 vector. Here, R21 vector is a unit vector from Q2 to Q1 along the line joining the two charges. So, F1 is equal to K into Q1, Q2 divided by R21 square into R21 vector plus Q1, Q3 divided by R31 square into R31 vector plus etc. up to Q1 Qn divided by Rn1 square into Rn1 vector.
Thank you students. Once again we will meet in the next session.